Hello. In this video we're talking about descriptive statistics, the kind of statistics that you produce to describe what's going on in a data set. And when we're producing descriptive statistics, there are usually two things that we want to describe. First of all, where the centre of the distribution of our data is, and secondly, how much spread there is around the centre of that data set. What we're going to do in this video is we're just going to look at the first of those two questions, and we're going to look at what are called measures of central tendency, the mean, the median, and we'll just touch upon the mode as well. Okay, so to give you an idea of what I'm talking about, let's look at some roughly normally distributed data. This is data on annual population growth per country from 2014 for almost 200 countries published by the World Bank recently. And you can see this is a symmetrical frequency histogram. There's little evidence of any skew in it. And you can see that there's a middle to that distribution, that's the centre, and then there's some spread. Some of the data are dispersed around that centre. So what we're talking about here is quantities that we can calculate which tell us where that centre is located. What's the location of our data? Let's look at an example with a small data set. So we're not going to calculate the mean of 196 countries or whatever it is. We're just going to look at the weights of 6 mice. Let's say you're doing an experiment in the lab and you've got 6 mice and you've weighed them and you come up with these numbers. So they range from 19 grams to 35 grams, but we want to know what's the mean weight of these mice. Well, the mean is calculated very simply. It's calculated by adding together all of the data and then dividing by the sample size. And that's what this little set of glyphs mean. X with a little line over the top represents the sample mean. The sigma, the thing that looks like a big E, is the Greek letter capital sigma. And that means take the sum of everything. And then X refers to all the data. So sigma X there means add all the data together. And then N is the sample size. So the arithmetic mean is equal to the sum of all the data divided by the sample size. We can do this quite easily because we've only got 6 numbers. So we can add together all of those numbers and we would divide that by the sample size, which is 6. So the mean of our data is equal to 161 over 6, which is 26.8. So the mean for this data set is 26.8 grams. What about the median? Well, the median is the middle number. If you take all of your data and you rank them, which means you put them in order, starting with the smallest and going to the biggest, then the median value is the one in the middle. So you rank your data, and we're going to do that with our data. There is no middle value here, and that's because we've got an even number of data points. If you've got an odd number, you take the middle value. If you've got an even number, you take the middle 2 values and you take the average of those 2 numbers. So in this case, our middle 2 numbers are 25 and 30. So we take the average of 25 and 30, which is equal to 27.5. So that's the median for our data. And the median can be thought of as being a value that divides the data set into 2. So if a number is above the median, then it will be in the upper half of the values. If a number is below the median, then it will be in the lower half of all the values in the data set. Why should we use mean or median? When should we use the mean or the median? Well, if the frequency histogram, so the distribution of data, is symmetrical, and you'd normally see this with normally distributed data, then the mean is going to be approximately equal to the median, and that's also going to be approximately equal to the mode, which is the most common value in the data set. So in that case, whichever one you use will give you roughly the same value, but we would generally choose to use the mean in this case, because the mean is an important component of, for example, how the normal distribution is built, and you can describe an entire normal distribution with just the mean and the standard deviation, which is a measure of spread. If you have an asymmetrical frequency histogram, however, then your mean will not be equal to your median, which will also not be equal to the mode. So if there is skew in your data set, then you'll find that these values are not the same. And it's worth just taking a minute to think about why that might be. So just to show you what happens to make the mean and the median different from each other, we're going to take our mouse data from before, but we're going to add an extra value to it. And this is a very heavy mouse. So whereas previously our values were between 19 and 35, we've now got a mouse that weighs 115 grams. Maybe a rat got into our animal house by mistake and we've weighed that. So what does adding this extra large value do to our values for the mean and the median? Well, the mean is equal to the total of our 6 numbers that we calculated from before, 161, plus the new value divided by 7, because the sample size is now 7. So our new mean is 39.4 grams, which has gone up from 26.8. So it's gone up by over 10 grams. The median, on the other hand, is now the middle value of our 7 numbers when we rank them, and that middle value is 30. So the median is 30, whereas previously it was 27.5. So what you can see is that the mean has been affected more by this extreme value in our data set than the median has. And this is why when you have skewed data, the mean tends to have a higher value than the median does. So the take-home message from this, a really important point, is that the median is not affected to the same extent as the mean by extreme values in the data set. We would say the median is robust to extreme values, or that it's robust to outliers. We would say that the mean is sensitive to outliers. Just to show you an example of why this is important, these data here, or this frequency histogram here, is data published by the UK Office for National Statistics, showing the distribution of household disposable income for individuals within households across the country. And you can see by looking at this frequency histogram that it is quite positively skewed. There are lots of people with not a huge amount of disposable income, and there are some people with a very large amount of disposable income. And you can see that they've drawn both the median and the mean on this plot. And you can see that the mean is rather higher than the median. So if someone says to you, well, the average amount of disposable income in the UK is £34,000, what you have to do is say, what do you mean by that average? Because if they're talking about the mean, then rather fewer than half of all the people in the population actually have that kind of money. If they're talking about the median, on the other hand, you know that half of the people in the country have more than that and half of the people have less than that. So when you're looking at skewed data, the median has rather more meaning than the mean does. Although, as I say, when you're looking at symmetrical data, the mean and the median are the same, and in those cases we prefer to use the mean rather than the median. So the second take-home message is, when your data are not symmetrical, you might consider using the median to describe the middle of the distribution, the central tendency. When your data are symmetrical, you should probably use the mean. Thank you.